I'd been secretly hoping that Poundland was going to extend its strings of LEDs into different colours, because up to now it's the longer strings, like 20 LEDs, it's tended to be cold white. And suddenly, this Halloween, we've got orange, purple and green. So let's check them out, shall we? Let's see how suitable they are for operation with nickel metal hydride cells with a slightly lower voltage than alkalines. So I can see a resistor tucked in here. This is the orange set, which would need a resistor, and they're typical, typical gallium arsenide style orange. Nice enough, quite sharp points, not super mega bright, but quite nice nonetheless. It's quite an attractive colour. So let's do the electrical test on that. We'll see what sort of voltage they're coming on at. Let's get the crock clips on and we'll see what sort of current they draw as well. So they're starting to glow. Actually, I should get the meter on so we can see the voltage as well. That's a better idea. The gallium arsenide type LEDs tend to operate at a lower voltage. So I would expect them to be around about 2ish, and bang on cue, they're starting to glow at 2 volts with a current draw of 20 milliamps. So I'm going to increase that a bit. Let's increase it right up to the 3 volts that you'd get from the a set of alkaline cells. So they're pretty bright at that. The voltage is, well, that's the voltage that would be supplied by the cells that's being displayed there. It will be dropped down over the resistor, and I'd guess it's going to be dropped down to virtually about 2 volts. I think I can actually just probe into that, across that, and see. 2 volts on the button. How good is that? That's very typical for the gallium arsenide. So yep, so turning it down to the 2.4 volts of the sort of voltage that the nickel metal hydride cell would sit down to, and they're absolutely perfect. They'll operate all the way down to the point the nickel metal hydride cells are discharged. So that's a good result, it's a good start. So let's move on to the next colour. And the next colour is the most promising one, well, in the sense that I quite like purple. I like purple LEDs a lot. A gallium nitride colour, possibly with phosphor to give it that colour, so let's stick the cells in. Turn it on. Oh dear, it was on. Oh, I can see a bad connection in there. That's not such a great score. This is one of these things that a lot of it's down to the fact that it's shitty lead-free solder causing problems. Yeah, it just doesn't look like it's taken. Okay, rightio. They're a nice colour. They're running on the very psychedelic on the camera here. They look a nice bluish purple. It's quite a deep but still quite bright colour. Let's see what voltage we can make them operate down to. So we'll get these on again. For people like us, it's an easy fix just to solder that with lead-based solder. For other people, non-technical people, they'd be probably huffed that their dollar store delight had malfunctioned. So yeah, these ones, the voltage has to be up about 2.5 volts before they start glowing. Having said that, they're quite bright at that. Let's nudge it down. Oh, down at about, what's it displaying? 2.42. Yeah, by the time the cells have gone down to their normal discharge rate, these are going to be very, very subtle. But I mean, it means they're going to last for a very long time because the current isn't even registering on the power supply. But at the full 3 volts of a fresh set of alkalines, it's drawing about 100 milliamps. So that would be about 5 milliamps per LED. Okay, moving on to the next colour. Which is green. Now, I've been quite delighted with the voltage that the other Poundland green LEDs operate down to. They go down to a very low voltage. If you recall the last ones, the spider lights, the sort of ones that came with these caps, they were operating right down to about 2 volts, which was really spectacular for gallium nitride LEDs. So let's start by sticking in these nickel metal hydride cells, turning it on. Typical bright green LEDs. Yep, looks pretty good. So let's pop that out and stick in the power supply. And crank it up until they start to glow. They're starting to glow. Let's turn the light off here. They're starting to glow dimly at about just over 2 volts. Can I go down any lower? Barely. I mean, they are lit. I don't even think, yeah, the camera is picking it up barely, but yeah, they're lit, but not that bright at 2 volts. But as I progress up to about 2.4 volts, which should be the running voltage of the nickel metal hydride cells, they are amply bright. Oop, I'm just getting a bad connection here. That's on my side, not the lights. Oh, they are very bright, and the current spread at that voltage, the current spread across them all is 23 milliamps. So the cells are going to last a long time. If I turn it up to the full 3 volts that you get from fresh alkaline cells, the current goes up to about 145 milliamps. So about 7 milliamps per LED. Yep, they're all good. I do like the purple ones. Slightly annoyed about that connection, but that's nothing that can't be fixed or just poked down. But in this case, I'll solder it. That's annoying. But having said that, we all know a lot of that's down to that horrific lead-free solder. But yeah, this is great. I really like these, so I'm going to put some cells in these and just leave them on test to see how they fare in the long term. But yeah, the purple's great. I really do like these colours. They're great.